All right, this is asynchronous work for chapter 8-3, and it's going to be test review too. So about the case closed, need help, give us a call. So refer to chapter opening case study on page 475. The bank manager wants to know whether or not the bank customer service agent generally met the goal of answering incoming calls in less than 30 seconds. We can appropriate this, approach these questions in two ways: by estimating the proportion of P, which is Z star, we use Z interval, right, of all calls that were answered within 30 seconds, or by estimating the mean of response time mu, which means we use a T interval, okay? Some graph and numeric summaries of the data provided below. So this is one of the data, and the other one is the box plot, okay? Let me double check if I'm sharing everything. So let's see. So I'm using this. Okay, so I just read this section. Now, so the question number one, so they gave you the computer output and box plot and histogram. Okay? And so let's see. Describe the distribution of call or response time to the random sample of 241 calls. So this is 241 calls. Describe the distribution of call response. All right. So let's look at the computer output. There are 241 calls. Mean is 18.35. So the average people had to wait is 18 seconds. Okay, this is second, right? And standard deviation is 11.76. It's a little bit skewed right. Maybe you can take a look of this and a little bit skewed right. Okay. So I'm sorry, so skewed right. So that was maybe if you remember socks, right? And SOS, SOC, S, right? Spread, outliers, center, and socks was S, and spread. Oh no, center. What's last S? I forgot. Oh God. So so let's see. Center is mean, so this is mean, or median. Yeah. For this case, maybe you can treat median, maybe, or maybe mean, because we have to use mean later. That's a spread is a range of 0 to 50 seconds, right? Or maybe standard deviation is another S, okay? No outliers, right? And spread, standard deviation is given. So that's number one question. Number two, what proportion of the call response times in the same sample was less than 30 seconds? Explain how you get the answer. Okay. If it's normal model, you can run the Z-score, the standard deviation, and you can cut off the 30 seconds and less. I was going to do that, but it's a skew right, so it's slightly off. So maybe you look at the histogram here, and let me enter, kind of, you have to estimate how many are there. So it's like this is 4, first being is 4 plus 14, so that's, I have to estimate a little bit. 26 and 17. Maybe that font a little bit smaller. Maybe a little much smaller. Okay. After 17, this is going to be 30, 33. And maybe 19. It's hard to read this. And 20. I use the line tool. And 10, huh? 10. 24. I hope you understand what I'm doing. So still it's 30 seconds, up to 30 seconds we have to do this. So this 24 right here. Did I include this? 10 seconds, okay, 10 people. 24, another 10. This one is 13. The last one here, huh? This is going to be 6, 5, 6, 7, okay? So let's see. Okay, I use a calculator. See, I tried to run through the normal CDF. Yeah, actually, this is pretty close. So, it became 83%, but this is better way. So kind of elementary way. So this is, let me see, 4 plus, it's hard to read this way. I don't know if you can see, 4 plus 14 plus 26 plus 17 plus 33 plus 19. Oh, sorry. 19 plus 20 plus 10 plus 24 plus 10 plus 13 plus 7. 197 out of 200. How many people? 200. How many people? 241. So what we can do is 241. I'm sorry, 197 divided by 241. 82%. Okay, 82, 81%, 82%. Let's see. Your answer key is 83%. So it's ironically that it matches with the normal CDF, but I think that my eyes a little bit not accurate to count like this way, you know. So let's go your answer key. So most likely some of them is 5, you know, this could be, I don't know which number. This could be 16 instead of 14. Okay, so it's 83 is a percent. Yeah. Now, if it's 83 is a percentage, just think about it. So this is number 2 question. What proportion of the call response times in a sample were less than 30 seconds? So that's 83%, right? Now, number 3, the bank's manager would like to estimate the true proportion P and calls to the bank customer service center that are answered in less than 30 seconds. Okay, question A, what conditions must be met to calculate 85% confidence interval for P? Show that the conditions are met in this case. Okay, so there are three things, right? Random. So of course this is random phone call. So the callers are calling me, right? So random. Okay, random is okay. Now 10% most likely is 241 is less than 10% of the all calls. So we assume 241 times 10, which is 2041 calls, right? So that's okay. Now, what else? The count has to be more than 10, right? It's not more than 30, this time more than 10, okay? Because it's the proportion. So we run the Z star. So those are conditional. That's letter A. Now, explain the meaning of 95% confidence in this setting. So we run the 95% and we try to get the true proportion, okay? So we don't know the true proportion of the callers who are waiting less than 30 seconds, but most likely that interval is going to be in this. So they gave you the answer already. A 95% confidence interval P is 0.783, comma 0.877. So this is the interval. Give the margin of errors and show how it was calculated. Okay, so 95% confidence interval. So what we have to do, I wonder if you remember, confidence interval and as a margin of error, give the margin of error. So this must be is the average of this must be the mean, right? So let's see. This is how I do it. It might be better way. So if they give you this kind of value already, so 0.783 plus 0.877, add it together, divide by 2, which is 0.83. That must be the mean of those two values. And plus minus value must be margin of error. So if you subtract whatever this, so let's subtract this one first. So 83, 0.83 minus 0.783, 0.047, okay? So if I add this number to this number, do I hit 0.877? Let's see. So if I add to 0.83, 0.877, so now it's bingo. So I wonder if you can see this. Maybe I put this one here. So this is a mean, 83%, right? So that's what we came up from this value. Ideally, if you add everything and you count it up to 30 seconds right here, that might be we count and divide by 241 is become 83%. Okay. Now, so margin of error must be 0.047. Okay. Give the margin of error to show how we calculate. Okay. How we calculate it was, this might be the case. I wonder if you remember. Let me write down. The formula is will be given, but it's going to be Z star, sorry. Oh, it doesn't show up. What if it shows up? This star mark show. No, star doesn't show up. Okay. What can I do? Just put the Z right now. Doesn't look like star. Let me see if I have, oh, star here. Okay, Z star and times square root fraction P hat. I just put hat later, and Q hat, Q is 1 minus P, right? So 1 minus P, and divide by N. And it shows up, okay, good. So, let's plug in whatever. So Z star for 95%, if you remember, it's going to be 1 tail, right? 1 tail. So let's see, let me clean up everything. And second bars, invert norm. So 95% is 5% is the tails. One of the tail is 2.5%, so 0.025, right? Mu is 0, standard deviation 1, so this is, I think, 1.96, yeah? Plus minus, right? So this is going to be, I forgot to put plus minus. So this is going to be plus minus, okay? So put the arrow sign. So it's going to be plus minus 1.96. Plus minus 1.96. That's the first thing. And square root, P is 83%. So 0.83. The failure of 83 is 17%, right? So it's going to be 0.17. Divide by 241. Okay. This might be margin of error. Okay. Let's see, this one comes out to, supposed to come up to the margin of 0.047. So let's see. 1.96 times square root, let me put the parenthesis here, 8.83 times 0.17, close the bracket, divide by 241. Move the cursor, enter. 0.47, look, so this number matches. Let's see, let me highlight this. So we kind of did this way. This is my way, and this is proper way. Oh, no. This is my way, and this is supposed to be where is it? Oh, this is supposed to be proper way. Okay, so let me highlight those. There's margin of error here. Margin of error right here. And I made sure this is going to be in 0.83 is in between. All right, so that is letter, where is it? Letter C, interpret the interval. So we are not sure that the true proportion of the customers who will be answered less than 30, but most likely it's between those. We're 95% confidence. So if we have many sample of 241 customers each time, we will settle in between those two. Okay, so that's the up to 1, 2, 3 questions. 3 has A, B, C, D. So that's the interpretation. I'll be back in number 4. Okay, so this is, I will pause the video and I will come back to the next video.